So when our friend asked this question, can we assume the list only contains integers, the client got back with this other doc test. Our client wants this function to work even for lists like this, which contain lists or strings. So our client is making it clear through this example that these lists could be arbitrary. Notice, however, that even though we have given this doc test, my generative AI is suggesting the same code as before. So it's important to remember that AI generated code can be incorrect. I cannot stress this point enough. We know, since we have just learnt about sets, that this code cannot work. If you try to run it on this example, this code would produce an error exactly like the one we just saw. It would not produce the answer that our client wants us to produce. So we must not blindly accept this code. Instead, what we're going to do is prompt our AI to use a different strategy. In this code, I have started by writing some statements of my own. I'm writing what we call a technical prompt. I'm trying to explain how I want my AI to solve this problem. I have a comment saying step 1, sort the data. And then when I press enter, my AI produced this code. Then I said step 2, count the number of unique items. And I even tried to provide my AI a hint about how I want the AI to count this. I started by writing the beginning of an accumulator pattern. I used a variable with a sensible name, initialized to 0, and when I pressed enter, my AI immediately recognized that, oh, this is the accumulator pattern, and the AI started suggesting this code. Let's just take a moment to see how this code is working. We are trying all the values of I in this range. Notice normally we try I in range len of data. Why has the AI suggested only range len of data -1? This range will start the values of I at 0, but we will go up to and not including this last index. Why does the AI not want to look at the last index I? Well, when we read the next line, we see why. We are going to compare data I with data I plus 1. If we let I go all the way up to the last legal index, then I plus 1 would be an illegal index and that code would crash. So the way I want my AI to work is first sort the data and then compare neighboring elements, items at index I and index I plus 1. And if those two are different, then we have found a different value and we would increase this count by 1. Now before we proceed further, our friend has a question. In step 1, when we sorted this data, couldn't we instead use the sort method on the list object? So basically, our code is taking the original data and making a copy of it which is sorted and then moving this label from the original object to this sorted copy. Our friend is pointing out that it might be more efficient to sort the data in place. Don't make a copy of it, just sort the given list. Now here we would have to check with our client. Do they want us to modify the given list? If they're okay with us modifying the given list, then perhaps our friend has a good suggestion. On the other hand, doing it this way is a little bit safer. If our client was not expecting us to modify the given list, then this might still work. It would just make a copy of the list and sort that copy. But in fact, if we think about this a little bit more carefully, we should not be sorting this list at all because the list is heterogeneous. What sense does it make to sort a list that contains lists and strings. In fact, if you try this out, regardless of whether you try it out with the sorted function or with the method that our friend was suggesting, we will get an error. And the error will tell us that we cannot compare lists and strings. It turns out that if the given list was made up purely of strings or purely of lists of integers, then you can actually sort that. You might wonder, what does it mean to sort two strings? Well, think about a dictionary that you're familiar with. In a dictionary, words appear in a certain order. That is called the dictionary order or the lexicographic order. And if you try to sort a list of strings, you will get those strings in dictionary order or lexicographic order. A very similar idea applies to lists of integers. So you can sort certain types of objects, but in this case we are getting an error message because we're trying to sort a list that contains both lists as well as strings, and we don't know how to compare two objects of different types. So unfortunately, this entire approach that we started by prompting our AI to try and do this is not going to work. Once again, I want to point out that at least today, the AI is not smart enough to catch this mistake. It's very happy to follow our prompts, but it's our responsibility to approach the problem in the correct way. This example shows that we can actually mislead our generative AI towards a solution that is not going to work. A smarter AI should have recognized that this approach would not have worked with one of the examples that we had given. But today's AI, at least when I'm recording this in the early part of 2025, it is not clever enough to detect this.